Welcome to Circuit 1C, photoresistors. This long-legged component with a white plate and what looks like a squiggly line on top is a photoresistor. It is the key to the nightlight that we're going to be building in this circuit. A photoresistor is just a resistor that has a different resistance based on the amount of light hitting it. The amount of light hitting the photoresistor is inversely proportional to its resistance. So, when the amount of light on our photoresistor goes up, its resistance goes down. When the amount of light on our photoresistor goes down, the resistance goes up. This variable resistance is nice, but our breadboard measures voltages, not resistance. So we're going to need to use a voltage divider circuit to convert this variable resistance into a variable voltage. The potentiometer from last circuit used a voltage divider circuit as well, but both of the resistors were in a way built into the potentiometer. In this circuit, we are instead going to need to explicitly add a second resistor to create our voltage divider. The equation for a voltage divider made from two resistors, R1 and R2, with an input voltage of V in and an output voltage of V out, can be given by V out equals V in times R2 over R1 plus R2. If we replace R1 with our photoresistor that varies its resistance when it is hit with light, V out becomes a varying voltage that we can measure. Note how, since R1 is in the denominator of this equation, when light goes up and the photoresistor's voltage goes down, V out goes up. So, we would expect the value that we measure to go up when we have more light and down when we have less light. In our code, we will use the idea of thresholds to only turn on our LED when the light we measure with the photoresistor gets low enough. That way, it can act as a nightlight. That's about it for theory for Circuit 1C. Now let's build the thing. We'll keep the hookups for driving the LED from pin 34 very similar to the previous circuits. Then, we'll add the photoresistor and a 10 kilo ohm resistor in the voltage divider configuration we just discussed. We will again connect the voltage we want to measure into our first analog input, A0. When you have two components as close together as the photoresistor and 10K resistor are in this circuit, make sure to be extra careful that you are putting them in the correct holes of the breadboard and that their legs aren't accidentally brushing up against each other, or this could cause unexpected behavior. Now let's drive our circuit with code. As usual, these first few cells are for setup, so we can control our LED and read from our photoresistor. Now, let's run this cell to get a value from our photoresistor. When I cover the photoresistor with my hand so less light hits it, and then run this cell again, we can see this value go down. Now, let's perform our nightlight operation. Notice this comment that says you can change the threshold to match whatever the lighting is in your room. Set this to something in the middle of what your photoresistor reads when you cover it with your hand and when you remove your hand. That way we can test our nightlight turning on and off by putting our hand over it. So, after updating this threshold value, we'll run this cell. And now we have a nightlight that turns on only when the light level gets low enough. If you're afraid of the dark, hopefully now you have the upper hand, as we've completed Circuit 1C and made our own homemade nightlight. Whenever you're ready, move on to Circuit 1D, where we'll upgrade our nightlight to have an RGB LED and control its color with a potentiometer.